Hi, welcome to Lesson 3.2, Properties of Graphs and Quadratic Relations. The goal of today's lesson is to describe the key features of the graphs of quadratic relations and use the graphs to solve problems. What I'd like you to do first is go to your textbook, open up to the appropriate page for section 3.2, and find the terms axis of symmetry, vertex, maximum value, and minimum value in the textbook. They'll be highlighted probably in the margin somewhere. Please write down then the definitions for each of these four terms. Okay, please pause the video and go ahead and do that. Okay, now that you've had a chance to do that, we'll just scroll up here a little bit using the mechanical scroll, and we'll take a look at our first example. Grace, being a golfer, hits a golf ball out of a sand trap from a position that is level with the green. And actually that should be with. I have to make a few corrections on my sheet, but they'll be corrected on yours once you get this worksheet. The path of the ball is given by the equation y equals negative x squared plus 5x, where x is the horizontal distance traveled by the ball and y represents the height of the ball in meters. Find the greatest height of the ball and how far away it lands from Grace. So what I'd like you to do, in a couple seconds I'd like you to pause the video so you can make a table of values and fill this in from 0 to 5 seconds. Now you'll notice that there's a few here that are sort of in gray, and what I'd like you to do first of all is just fill in the values for the white cells first. Then if you see that it might be difficult to exactly find the greatest height, then plug in these values for x into your equation and calculate these y values to see if that may give a little bit of added clarity as to what the greatest height of the ball is. Okay, so pause there for a second. Actually, I'll go ahead and do the hardest one for you just to get you a little head start here. So if I plug in 0 in for x, for negative x squared, and 0 in for the x here, 5x, then with doing a little bit of mental math, we see that that is 0. Okay, now that the more difficult one is finished, the rest of them should be a little bit easier for you. So please go ahead and continue filling out the white cells of the table of value, and then perhaps the gray ones if necessary. Okay, and then we'll come back in a couple seconds to get the grand conclusion for this example. Okay, so I trust that you have filled in the rest of the cells here. And now what I'd like you to do is to take a look at the x value at the maximum height of the ball and see how that relates to the x values of the points where the ball takes off and lands. Okay, so where did you see the x value of where the ball takes off, and what would be the y value if we were leaving from the ground? What would be the y value indicating that the ball is then taking off, and what would be the y value when you see that the ball has landed again? Once you take a look at those two values, examine those two x values, and see if you can figure out how it could be that you could determine the height where the x value of the maximum height is. Okay, and so take a close look at that, and just a little hint here, could perhaps the midpoint formula that you learned in chapter 2 be useful in this way. Okay, so what do you notice about the x value for a maximum of, this is, as you know, is called a quadratic, a parabola, in relation to the x values of the two, I guess, x-intercepts, where y is 0. What do you notice about that? That feature or property of quadratics will happen for every pair of x values for any one single y value. So where the x-intercepts occur, the maximum will occur in that special position between them. Also, if you were to say, okay, well, what about when y is 3 meters? You know, if you could determine the x values where that happens, those two times, then the maximum would occur again in some special location between those two values also. Okay, so it'll happen anytime along there. So think about that for a couple seconds. Pause the video if you wish, and otherwise we'll return to this video or this example in a couple seconds just to do a little wrap up. Okay, pause the video if you wish, and then we'll proceed on to example 2. Okay, now that we have gone on to example 2, we'd like to graph each quadratic relation and determine the coordinates of the vertex, the equation of the axis of symmetry, the maximum or minimum value, the y-intercept, and the zeros. Okay, so I trust you recall how to substitute in values into equations and find the values of y for each of those corresponding x values, and then plot the points on these handy grids that are given to you. Just use intervals of 1 unit for each of the each indicator, and then draw a smooth curve through those points, so then you can determine each of these things. Now you looked up the equation of the axis of symmetry, you looked up what maximum and minimum values are, what the vertex is. So if you could then go through and just put a little list down here to the right of example 1 and to the right of example 2 here, indicating the different features of the quadratics, then we'll come back and take a look at those. Okay, so go ahead and do those, and I'll give you the big reveal in a few moments. Okay, so here are the tables of values and the plotted points, and we can fill out the basic values that we are looking for. So the coordinates of the vertices, the vertex for example 1 here, we see the vertex is where the turning point is. So we see that actually was 1, 2, 3. So for part A, that's 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, which is also right here in the table of values, the maximum y value that we see there, so that's 9. For part B, the equation of the axis of symmetry, well, that is where the graph is divided in two horizontally, and that goes actually right through the vertex. So that's at x equals 3. Quite coincidental there. C, the maximum or minimum value, and that's actually just the y value. It doesn't mean the point. The point is given here at the vertex. So the maximum minimum value is y equals 9. And part D, the y-intercept. Well, if we take a look here, actually in the table of values we see that it's at 0, and from the graph we see that that would continue on to 0 there. So the y-intercept is y equals 0. And for part E, the zeros, that's at x equals 0 and x equals 6. And we can then sketch this, just complete all the points. Try to make it a curve. Okay, so what I was mentioning before in the first example is that the axis of symmetry, or the vertex, is halfway between the zeros. So you could use the midpoint formula. 0 plus 6 divided by 2 gives us 3. So the midpoint formula would give us the 3 for the x value of the vertex. But also, if we were to take this point here, this x value is 1, this x value is 5. So between these two x values, 1 plus 5 is 6, divided by 2 is 3. Again, halfway between those 2 points. This x value is 2. This x value is 4. 2 plus 4 is 6, divided by 2 gives us 3. Okay, so the vertex in the axis of symmetry is halfway between any pairs of points where the y values are the same. Okay, just to clarify what I said in example 1. Now if we go over here to example, or part 2 from example 2, we want to take a look at the vertex. And the vertex we see now, because it is, as you can see, this is positive. It's a positive coefficient. This is a negative. So negative, when if we look at quadratics, they could either be frowning faces or smiling faces, and a negative could indicate perhaps a negative person, somebody who's not very happy, therefore they have a frown. So that's opening down, just as a little clue for you. And then if it's positive, somebody who's a positive person, they're smiling, therefore it's opening up. So now instead of even though it's positive and it's opening up, we're now not looking for a maximum value, we're looking for a minimum value. So we want to look at the table of values to find out which is the lowest y value to indicate the coordinates of the vertex. And we see that the lowest one is negative 4.5, so the vertex then is 3, negative 4.5. B, we want to find the equation of the axis of symmetry. Well, that's going to be exactly where the vertex occurs. And so that's going to be x equals 3, coincidentally enough. The maximum or minimum value, well, this is going to be a minimum value, so y equals negative 4.5. D, we want to look at where the y-intercept is. Again, the y-intercept is going to be at 0, 0, 0. And E, we want to look at the zeros themselves. So in this case, it's going to be where y is 0. So again, x equals 0 and 6. Now that obviously won't happen all the time, just happens in these two equations, these two examples. It happens to be that. Again, between any pair of y values that are the same, those two x coordinates are going to be the same distance away from the axis of symmetry. Again, between these two, again, and the zeros too. Okay, so the x values are of the same distance from the axis of symmetry for each of those points where the y values are equal. Okay, digest that for a couple seconds, and then we're going to do a little bit of work here on a graphing calculator for this last example here.